Good day, everyone. My name is Mary Jane Duan, and I will discuss the uncertainty and probability in statistics. The uncertainty is the experimenter's base estimate of how far an experimental quantity might be from the true value. The art of estimating this uncertainty is what error analysis is all about. For example, a survey might report a 95% confidence level of between 4.88 and 5.26. That means if the survey is repeated using the same methods, 95% of the time the true population parameter will fall between 4.88 and 5.26, 98% of the time. The mean error refers to the mean average of all errors. Error in this context is the difference between a measured and true value. So, the 95% is the true value, the 98% is the average, which is the error. So, let's proceed to the next probability. Probability is the measure of the likelihood that an event will occur in a random experiment. So, when we say random experiment, it is an experiment or a process for which the outcome cannot be predicted with certainty. So, the sample space are denoted to C of a random experiment is the set of all possible outcomes. So, probability is quantified as a number between 0 and 1, where loosely speaking, 0 indicates impossibility and 1 indicates certainty. The higher the probability of an event, the more likely it is that the event will occur. A probability of 0 means that the event will not happen. So, for example, a probability of 0, if the chance of being involved in a road traffic accident was 0, this would mean it would never happen. You will be perfectly safe. A probability of 1 means that the event will happen. So, here's the example of probability of 1. Each of the letters below is written on a card. A card is chosen at random from the bag. So, here's the example of probability. So, example number 1, question number 1. A die is rolled. Find the probability that an even number is obtained. Solution. Let us first write the sample space S of the experiment. So, sample space, it is the random experiment. So, S equals open bracket 1, 2, 3, 4, 5, and 6. Then let A be the event. An event number is obtained and write it down. The A is equal open bracket 2, 4, and 6. So now, we use the formula of the classical probability. So here's the formula. P parenthesis E equals N parenthesis E over N parenthesis S. So the A is here 2, 3, 2, 4, and 6. That's why it will 3. Then the S is 6 because 1, 2, the ansod sa parenthesis is unuman. That's why 6 ang gibutang sa S. Then, kung ato ikuan ang 3 of X, ato ang makuan pa man siya, ma-count off pa man siya, so it will 1 over 2. Ma-divide the I rather. So, 1 over 2. 1 half ang answer. So, let's proceed to the last example of probability. Example number 2, question number 2. 2 coins are tossed. Find the probability that 2 heads are obtained. Note, each coin has 2 possible outcomes, each heads and tails. So, solution. the sample space is given by, so the sample space is open bracket, parenthesis, H and T, then comma, then parenthesis, H, comma, then head, parenthesis, comma, parenthesis, tails and heads, parenthesis, tails and tails. So, ang sod sa sample space. Then, let's proceed to the sa A. Let A be the event. 2 heads are obtained. So, A equals bracket, parenthesis, head, and head ang sod sa event. Then, we use the formula of the classical probability. So, gamito na sad nato ang classical probability. So, pareha gyapon og kanang formula. So, ang A kay usara man ang iyahang event, that's why usara sad. Ang ibutan kay sud man sila sa bracket, kumbaga sud man sila sa usa ka parenthesis, kumbaga usara sila ka set. Then ang S kay upat man ang iset. Tas tagsaman 1, 2, 3, and 4. That's why 4 ang S. So, ang final answer is 1/4. So, that's all. And thank you. Keep safe and God bless.